Continuous. Deconstructed means locally constant. So, calculus means to reunite, locally constant, per numbers. themathacademy.net. February 2023. Alan Tarp, @gmail.com.
Paranumbers at as areas, called integral calculus. We ask, 2 kilograms at $3 per kilogram, plus 4 kilograms at $5 per kilogram, is 6 kilograms at how many dollar per kilogram? We see, that unit numbers add directly. But, that paranumbers must be multiplied to unit numbers, to be added. And, since multiplication creates areas, paranumbers add as areas, under the paranumber curve. So, in integration, multiplication comes before addition. Therefore, paranumbers and fractions are not numbers, but operators, needing numbers to become numbers. Here, the paranumber curve is piecewise constant. It becomes locally constant by interchanging epsilon and delta. Then the sums are replaced by integrals. Subtracting paranumbers is called differentiation. Reversing adding paranumbers, we ask, 2 kilograms at $3 per kilogram, plus 4 kilograms at what, gives 6 kilograms at $5 per kilogram. We first pull away the initial 2 by 3 block, before we recount the rest, in fours, to get the paranumber. So, reversed paranumber addition means subtracting areas, to be reshaped, called differential calculus. Here subtraction, giving a change, delta, comes before division, the reverse of multiplication before addition, in integral calculus.
Formal definitions of the three types of constancy. With prices, a paranumber sometimes changes from one constant to another. But what to do with a constantly changing paranumber, such as a free-falling object's meter per second number, also called speed? Again, the area under the paranumber curve gives the answer, as variable numbers are usually locally constant, continuous. There are three kinds of constancy that are formally defined as follows. A variable number y is globally constant c if the distance from y to c is less than any positive number, epsilon. A variable number y is locally constant c if the distance from y to c is less than any positive number, epsilon, for some interval radius, delta. A variable number y is piecewise constant c if, for some interval radius, delta, the distance from y to c is less than any positive number, epsilon. Likewise, there are formal definitions for the three types of linearity. They are defined as follows. A variable number y is globally linear, c, if the distance from delta y over delta x to c is less than any positive number, epsilon. A variable number y is locally linear, c, if the distance from delta y over delta x to c is less than any positive number, epsilon, for some interval radius, delta. A variable number y is piecewise linear, c, if, for some interval radius, delta, the distance from delta y over delta x to c is less than any positive number, epsilon. Likewise, there are three ways to be linear, defined as follows. A formula, y equal f of x, is globally linear, if the paranumber, delta y over delta x, is globally constant. A formula, y equal f of x, is locally linear, if the paranumber, delta y over delta x, is locally constant. A formula, y equal f of x, is piecewise linear, if the paranumber, delta y over delta x, is piecewise constant. One difference sums up many differences. Local constancy means constancy over small intervals. So, the area under the paranumber curve is found by summing up many small area strips, quickly done on a computer. However, there is a shortcut. Summing up many differences makes all the middle terms disappear, thus leaving only one difference between the end number and the start number. So, the task is to rewrite an area strip, y times dx, as an area difference, dA, so that dA is y times dx, or so that dA over dx is y. This is called differentiation. If, for a small exchange, dx, the area strip, y times dx, equals 2 times x, times dx, can be written as the difference, dx squared. Then summing up the area strips, from 1 to 4, simply gives the total area, as the difference in x squared, from 1 to 4, that is, 4 squared, minus 1 squared, or 15. This result is confirmed on a CAS calculator. If we use an old-fashioned S, as a symbol for a sum of small changes, we can now write area equals indefinite integral 2 times x, dx, from 1 to 4, equals the change in x squared, from 1 to 4, equals 4 squared, minus 1 squared, or 15. Book shadows reveal change formulas. The narrow shadows, of a rectangular P times Q book, indicates the never falsified formula. D, P times Q, is, dP times Q, plus P, times dQ. Or, as percentages. D, P times Q, over P times Q is, dP over P, plus dQ over Q. So that, d, x squared, is, dx times x, which is 2, times x, times dx. And d, x cubed, is, dx squared times x, which is 3, times x squared, times dx. Etc. The Euler number, E, has its own change formulas. The number, E, is defined by, e to the power t, is 1 plus t, for small t, giving also, that t is the natural logarithm of, 1 plus t. We now see, first, that under differentiation, e to the power x, gives itself. Next, that under differentiation, the natural logarithm of x gives, x reciprocal. Finally, that under differentiation, sine gives cosine, and that cosine gives negative sine.
There are 4 ways to unite, or to split a total. A number formula t equals 345 equals 3 bundle 4 bundle 5 is called a polynomial. It shows the 4 ways to unite: addition, multiplication, power, and next to block addition, also called integration. Addition and multiplication unite changing and constant unit numbers. Integration and power unite changing and constant pair numbers. We might call this beautiful simplicity the algebra square, since in Arabic, algebra means to reunite. The 4 uniting operations each has a reverse splitting operation. Addition has subtraction, and multiplication has division. Power has the factor finding root, and the factor counting logarithm. Integration has pair number finding, also called differentiation. Reversing operations means solving equations, done by moving to opposite side, with opposite calculation sign.